At the end of the topic, you will be able to define radioactivity, explain nuclear fission, define nuclear fusion, list down the precautions when exposed to radioactive material.
The discovery of radioactivity was purely accidental. Henri Becquerel, a French scientist, was interested to study about fluorescence. When ultraviolet light falls on certain substances, it is transformed into visible light called fluorescence. In February 1896, Becquerel was conducting an experiment exposing uranium-bearing crystal to sunlight. The crystal, when placed on a photographic plate, produced its image on the plate. Becquerel theorized the absorbed energy was being released by the uranium in the form of X-rays. Becquerel repeated his experiments in light-tight box, in which some minerals and photographic plates were kept together. It was clear that the radiation that affected the photographic plates came from the mineral itself. Many interesting phenomena are observed in certain heavier elements. We shall see such behavior now. The spontaneous decomposition of unstable atomic nuclei to form nuclei with a higher stability is called radioactivity. For example, the unstable heavy nuclei uranium undergoes spontaneous decomposition and emits radiation such as alpha, beta and gamma rays. Radiation is the release of energy and particles during the decomposition process. Place a small quantity of a radioactive substance in a block of lead. The arrangement is to make a narrow beam of radiation to come out of the cavity. These radiations are then exposed to strong magnetic field at right angles to the plane of paper. The beam is seen to split into three different components. The rays deflected to the left are called alpha rays, that onto the right are called beta rays, and the undeflected rays are the gamma rays. When the beam of radiation is exposed to electric field, it is seen that alpha and beta particles are deflected towards the negative and positive plates respectively. The undeflected rays are the gamma rays. The alpha rays are composed of positively charged helium nuclei, beta rays are made of electrons, and gamma rays are the high-energy electromagnetic radiations. When nucleus can be split, man naturally began to think if two nucleus can be fused. This resulted in a great scientific discovery of nuclear fusion. When two or more atomic nuclei join together to form a single nucleus of greater mass, it's called nuclear fusion. This is usually accompanied by the release or absorption of large quantities of energy. Let us consider the fusion of hydrogen nuclei. The fusion of hydrogen involves the following reactions, giving positrons, neutrinos and gamma rays. A large amount of energy is released, which can be understood from the last reaction. The mass of 4 protons and the mass of products are not the same. The difference between them appears as energy. These reactions are a part of what is usually called the proton-proton cycle, which yields about 25 million electron volts. For a nuclear reaction to happen, light nuclei must gain very high kinetic energy. This energy is equivalent to a temperature 80 into 10 to the power of 6 Kelvin. The fusion reactions that happen under such high temperature are called thermonuclear reactions. These kinds of reaction take place in stars such as Sun.
Nuclear reactivity is a measure of the departure of a reactor from criticality. It is a useful concept to predict how the neutron population of a reactor will change over time. If a reactor is exactly critical, that is, the neutron production is exactly equal to the neutron destruction, and then the reactivity is zero. If the reactivity is positive, then the reactor is supercritical. If the reactivity is negative, then the reactor is subcritical. Alpha, beta, and gamma radiations are all ionizing radiations. These radiations cause a change in the structure of molecules in cells, disturbs the normal functioning of the biological system. The extent to which the human organism is damaged depends upon the dose and the rate at which the radiation is given, and the part of the body exposed to it. The damage may be either pathological or genetic. The radiation exposure is measured by the unit called Roentgen, R. 1 Roentgen is defined as the quantity of radiation which produces 1.6 into 10 to the power of 12 pairs of ion in 1 gram of air. Safe limit of receiving the radiation is about 250 milliroentgen per week. The following precautions are to be taken for those who are working in radiation laboratories. Radioactive materials are kept in thick-walled lead container. Lead aprons and lead gloves are used while working in hazardous area. A small microfilm batch is always worn by the person, and it is checked periodically for the safety limit of radiation. Nuclear devices can be operated using remote control system. Clean up contamination in the work area promptly.
In this topic, you have learned the spontaneous decomposition of unstable atomic nuclei to form nuclei with a higher stability is called radioactivity. Radiation is the release of energy and particles during the decomposition process. The discovery of radioactivity was purely accidental by Henry Becquerel. The radiations are classified into alpha rays, which are composed of positively charged helium nuclei, beta rays, which are made of electrons, and the undeflected gamma rays, which are the high-energy electromagnetic radiations.